Welcome to Carlton's Math Corner. Today, we're going to continue our study on solving equations with variables on both sides. At this time, please make sure you have your math journal, your vocab packet, as well as something to write with. So our target today is I can find the value of x given two figures that have the same area or perimeter. So let's look at, first of all, perimeter. And what do we know about perimeter? Exactly. Perimeter is the distance around a figure. So really we're just adding up all the sides. And for rectangles, a quicker way to do that is we can take 2 times the width, because the width on both sides are the same, and then 2 times the length, and then add them together. And that would be even quicker than adding all the way around. Now a triangle, we can only do that if it's an equilateral triangle or if it's an isosceles triangle where 2 of them are the same, and then we can just multiply by 2 to put them together faster. Okay, so let's use perimeter and put these two equal to each other, because it says right here that their perimeters are the same. And so we are going to add up what we know, just looking at the terms of what we know, and we're going to add them all together and then try to figure out what x is. So let's start with the rectangle. First of all, I want you to notice what was done. How are these two similar? Exactly. This is actually, this is adding all the way around. And then this one is just taking 2 times the width and 2 times the length. But both of them will simplify down to 2x plus 2x plus 10. Okay? So whichever way is best for you, use it. But you will get down to the same answer. Now looking at the triangle. The triangle, notice, how are these two the same? Exactly, these two, well, this one right here is just adding all the sides. This one is actually taking 2 times this because these two are the same. And so we get 4x. But notice, no matter which path you take, you still get 4x plus x plus 5 in the end. Now it has turned into just a multi-step equation that has a variable on both sides. And we are excellent at solving for the variable when we get to this point. And so now we're just finishing out our steps to figure out what x is. So what did they do first? What's step number 2? Step number 1 was trying to find those perimeters. So that's what we got down to. And then step number 2, what happened? Yep, moving that variable to one side. So they combined like terms and they moved a variable to one side. And then step 3, try to get the variable by itself. So get rid of anything that's being added on or subtracted on. And then step 4, multiply or divide, whatever the inverse is, to get the answer. And we find out that x is 5. Now, we have found what x is. Now we can actually figure out what the perimeter is. Because if I put 5 in here, so if I put 5 in where x is for all of them, so this one would be 5 plus 5, which is 10. So that means this is also 10. So we have 10 plus 10, and I'm just going to write this in here, which is 20, plus over here we have 5 and 5 again, so 10. So 20 plus 10 is 30. So the perimeter is 30. And this triangle should also have the same perimeter. If we worked it right and found the right answer, it should work as well. So if I put a 5 in here, 5 plus 5 is 10. And then we have also 2 times 5, so another 10, and 2 times 5, another 10. 10 plus 10 plus 10, still 30. So yay, our answer checked out. X is 5. Okay, so the steps that we did. Once each perimeter is equal to each other, we basically combine like terms. We got rid of any parentheses that we were using. Like here, we added them all up and got 2x plus 2 of these. But in order to get rid of this, we have 2 times x and 2 times 5. And that's how we got 2x plus 10. So it's using the distributive property. But we're basically in step number 1, we're just trying to find the perimeter. We're adding up the terms that we know. And then number 2, getting rid of the variables, moving things to one side. Then we added or subtracted any of those lonely terms. And then the last step, we multiply or divide to figure out what the variable is, what the value of that is. And x was 5. Okay, now let's look at area. Okay, so let's just remind ourselves of what area is. Remember, area is the amount inside a figure. So if I'm trying to find the area of a rectangle, well, I know that the area is length times width. And so I'm going to use that knowledge to set these areas equal to each other and try to figure out what x equals. And so let's start off with the first rectangle. If I take the length times the width, I'm going to take 2 times the group of 5x minus 4. So it looks like that. And then on this one, I'm going to take 4 times the group of 2x plus 3. So I am going to need to use the distributive property in order to get this in simplest form so that I can start solving to figure out what x is. So 2 times 5x is 10x, and 2 times 4 is 8. And same thing on this side, we get 8x plus 12. Now notice the steps remain the same as all the previous problems that we have done. Trying to get the variable to one side, getting rid of adding and subtracting, and then lastly, multiplying or dividing. Remember, we're always doing the inverse, and we find out that x is 10. And we can even try this out. We can put 10 in here. 5 times 10 is 50, minus 4 is 46, and then length times width, so 46 times 2 is 92. And so my perimeter would be 92. Or not perimeter, my area would be 92. And then over here, we have 4 times 2 times 10 is 20, plus 3 is 23. So 4 times 23, and it's still 92. And when I am labeling area, I always put a squared, unit squared. And that's how I label it. If we go back to our perimeter problem, we always label it as just units. Okay, and this is kind of a reminder from last year. Okay, so now what I would like you to do is I want you to try these problems for tomorrow. Okay? So these are your ticket problems. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.